All right, hello guys. Today we're going to be talking about the linked list cycle problem. That's LeetCode number 141, easy categorization. So I really like this problem, especially when you're first starting to learn how to conduct your coding interview problems, because it utilizes a very common pattern that you're going to be using with linked list and also arrays. Primarily the fast and slow pointer technique or two pointers technique. So if we look at the problem statement, it basically says given the head of a linked list, determine if the linked list has a cycle in it. So what essentially is a cycle? It means, like, let's say you have like a line and it just basically crosses over itself at one point. There's a cycle in a linked list if there is some node in that list that can be reached again by continuously following the next pointer internally. POS or pos is used to denote the index of the node's tail that tail's next pointer is connected to. Note that pos is not passed as a parameter for this LeetCode question, and then your output's going to be true if the cycle is a linked list, and otherwise it's going to be false. So let's look at the input that they gave us. So 3, 2, 0, 4. And if we remember a linked list, it's category or characteristics. Essentially, if you remember, it's easy to delete a node and insert it. So that's all in one time. But its disadvantages are actually searching. So if you wanted to search for a single element, let's say that you looked at this linked list and wanted to look for 1, it's going to take you n time. Thankfully, for this problem, we're just checking if there's a cycle. So for this one in particular, and actually let me undo some of the steps because I got one of the, actually let's keep that. Just change the color of the linked list. So that will be a -4 right there. Okay, so we can see here, if we just were to draw it out, which is another great piece of strategy and advice for your program interviews, how would we know if this was a list or this was a cycle? If we just go next, 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 and then next, one way we could tell is that it never reaches null, right? So how would we be able to tell that? Well, one way is the two pointer or fast and slow pointer technique. So let's say we have 2 pointers. One is going to be denoted by this orange. Let's call that slow. And then let's say the other, which is red, let's say that's fast. Let's say they both start at the starting node out of the head of the linked list. And let's say the slow pointer moves 1 each time. So if it moves 1 each time, its next one is going to be that. Let's say the fast pointer is going to move by 2 each time. So its next move is going to be right here. If there's a cycle at some point, this fast and slow pointer will meet again, and that's true, then you have a cycle. Let's use the same numbers, but show a linked list that doesn't have a cycle, but actually points to a null at the end. So same values, except this -4 at the end doesn't point to 2, it points to null. So this fast technique, after it leaves the initial stage, it's going to go to 0. We'll have our slow pointer here after the first iteration. Then this next one's going to try to go to null. But in our code, in our logic, if it ever reaches null, then we know that this linked list does not have a cycle because it eventually ends. However, in this first example where this pointer ends back at 2, this pointer is going to eventually meet back at some point. So let's do this again. So now we have this fast pointer here. It's going to move twice. So it's going to move back here. That slow pointer is going to be at this 0, and then on the next iteration that orange is going to be right there, and because the fast pointer moves by 2, it's going to meet right here. So some point in our logic, it's going to meet at the same point, and it's going to cycle. So that's how we know there's a cycle in our linked list. So how do we show that in code? Well, we can easily show that in code by actually having 2 parts of our code where we take the head of the list, and you basically just make copies of that input. So if the input's head, we can have a slow pointer equal head. We can have a fast pointer equal head too. And then we could just do a while loop. So while slow and fast fast.next. So why is fast.next important? Because just in case at that point we already have like a linked list that only has 1 element. But then we check, because they both start the same one, we're going to actually do the fast, move it twice, so fast.next next, and then for slow it's going to be just simply by 1 slow.next, and then after that we're going to have our simple condition if slow.val equals fast.val, then we're going to return true. And then if it eventually ends out of this, we're going to return false. So throughout this whole logic, we're able to tell by kind of just using 2 pointers, a slow and fast one, which are showcased right here. Slow and fast. If this cycle, they'll eventually meet at some point. If not, it's going to break out and return false. So what's the time space complexity of this particular problem? So we're actually going to be doing this in O(n) time because we don't know how big the linked list is, and then also we can assume that we're going to at least run through each element at least once. But thankfully for this problem, the space is 0. Sorry, it's constant. It's 1 because we're only using pointers, which don't add any additional complexity. So let's code this out. We're going to first do that in Java. Okay, so in Java, we're going to reflect that same logic. So one thing with these questions, we're always also going to want to check if input is null. So if it's null, we'll just return false. Then we're going to create our 2 copies of the linked the linked list or list node in this particular problem. So one important thing to notice too is that we are checking this while statement through slow, fast, and fast.next. And the reason we have fast.next is just in case, again, if we only have a linked list that has 1 element. And then also notice where we actually add these next iterations of fast and slow linked list nodes. So before we can actually reach the if slow equals fast part, which would return true, we don't want it to return true in the first one because we haven't even checked if they cross paths later in the link with the list node, linked list list node. So what we want to do first is actually move those pointers at their pace. So remember, slow moves by 1 at each iteration and fast moves by 2 at each iteration. And then if at some point one of those list nodes hits null, it's going to break out of this while loop, and then we can return false because there is no cycle. But at some point, if these list nodes equal, it will return true. So that's the solution. Again, O(n) time, O(n) space. So let's do it in Python now. Okay, So in Python, we're going to have the same structure. So if head is none, we're going to return false. We're going to create our slow and fast copies of the list node. We're going to do our while loop. And let's just do slow and fast up next. We're going to do our iterations of slow and fast. Remember, at each iteration, the slow is going to move by 1 and the fast is going to move by 2. And at some point, if they do equal, then we return true. And if that's not the case, then we eventually at slow or fast hit a null, and then we return false because there is no cycle there. Oh, and I need to make sure that's uppercase. And that's how you solve it in Python. So this is an on time and on space because all we're using is pointers. So the key thing to remember in this problem is that we're using a 2-pointer or a slow and fast pointer. So just remember, if you have to check cycles, this is actually a great technique to use, and basically make sure that we don't have to use an additional data structure like a hash map or a hash set or other collection in order to determine if something has been visited or not, even though that is a viable solution as well. Anyways, guys, thank you for tuning in, and see you guys in the next video. Cheers.